So let me switch gears a little bit and tell you a little bit more about my book and about volcanoes. This is my first novel, Ashfall. And it's about Alex, a 15-year-old in Cedar Falls, Iowa. And one day, Alex's mother decides she wants the whole family to visit relatives in Warren, Illinois, just for the weekend. But Alex doesn't want to go. He's got his computer, his bike, his friends, everything he likes is in Cedar Falls. The only thing in Warren, on his uncle's farm, are goats, stinking goats. And so Alex whines and complains and complains and talks his mother into letting him stay home alone, just for the weekend. He's 15, he's a pretty responsible guy. What can go wrong, she figures? Well, what does go wrong is, well, Alex is home alone. The Yellowstone supervolcano erupts. Now, who here has heard of the Yellowstone supervolcano before today? Awesome, cool. Who here has heard of Old Faithful at Yellowstone National Park? Who has no idea what I'm talking about when I say Yellowstone National Park? It's okay, I just want to know. All right, that's cool. So Yellowstone's our first national park. It's in northwest Wyoming. And it was made our first national park because it's full of these amazing geological features. There are places where water comes out of the ground so hot it's already boiling. Geysers like Old Faithful. A geyser basically shoots water and steam into the air. Some of them hundreds of feet, some of them on a regular schedule like Old Faithful every couple hours. Some of them only erupt every few years and you never know when they're going to erupt again. And these things are powerful jets of water shooting hundreds of feet into the air. So if you have a geyser at Yellowstone, that's kind of like a fountain in the city park, right? They both shoot water in the air. But the fountain in the city park is powered by something. It's got electricity and a motor and a pump, usually. So, but there's none of that under Yellowstone. What powers the geysers at Yellowstone? Heat, very good. What causes the heat? Magma, exactly. Sometimes people say lava, but of course the correct technical term for lava underground is magma. There's a plume of magma under Yellowstone National Park, 425 miles deep. It shoots up at the surface of the earth like a blowtorch. And every few 100,000 years, that plume of magma develops enough temperature, pressure, dissolved gas. Sounds like I'm telling a really stupid joke, right? It gets gas, so it erupts. But no, it's true. Now this is a model volcano my nephew Max built me. And Max, when he built this thing, he was 15. And I thought it was really cool that he built me this model volcano because it's got fans and lights and the streamers and stuff. And so I didn't have the heart to tell him, Max, that's the wrong kind of volcano. This is a normal volcano, a Palladian volcano. This is like Mount St. Helens, Krakatoa, Vesuvius, any volcano you've heard of, if it wasn't in Hawaii, was probably a Palladian volcano. You all know how these work, right? The ones in Hawaii are a different type, called shield volcanoes. So these stuff comes out the top, it falls nearby, and it builds up this distinctive cone-shaped mountain. Everybody got that, right? Supervolcanoes are different. When a supervolcano erupts, if there was a mountain there before, it's blown away, destroyed. And the supervolcano exhausts so much material from deep under the Earth's surface, way down here, that when it's done, the ground collapses. And all that's left is a hole. Properly, that's called a volcanic caldera. So how big a hole? Well, the last time the Yellowstone supervolcano erupted as a supervolcano was 640,000 years ago. There was an eruption 70,000 years ago, but very small, not supervolcano. And it left a hole in the ground, 45 miles long by 34 miles wide. How big is that? That's kind of hard to envision, right? Now usually when I'm giving this talk in Indiana or Iowa or Ohio or wherever, I'll ask, has anybody been to Chicago? I assume you've all, everybody been to Chicago, right? Yeah, figured. So take the city of Chicago proper, just the city, not the suburbs. And I could put the entire city of Chicago down in that hole Yellowstone left, and it would just barely fit. The square mileage is about the same. And if I were standing at the lip of that awesome hole that just opened up in the ground, 45 miles long by 34 miles wide, and looking down at the city of Chicago I put down there, I'd be looking down at the top of the Sears Tower. Now sort of the Willis Tower, but nobody calls it that, right? The Sears Tower, 300 feet below me. So imagine, if you can, a hole in the ground as large as Chicago and deeper than the Sears Tower is tall. And that's the kind of massive cataclysm I'm writing about in asphalt. So if that happened now, today, while we're sitting here, would we notice it in DeKalb? Yeah, maybe. What would we notice? What do you think we notice? Those of you saying ash. How long do you think it take the ash to get to DeKalb? We're about 1,000 miles as the crow flies. No, more like 11 or 1,200. I'm sorry, 11 or 1,200 miles as the crow flies east. So I had to figure it out, right? Because I wanted to write a realistic book of what really would happen, what really could happen when the Yellowstone supervolcano erupts again. Because someday it will erupt again. It's an active volcano. If it weren't, all those geysers would quit. And so we know it's still active. So a normal volcano, a Plinian volcano like this one, throws ash anywhere from 10 to 50,000 feet into the atmosphere. But a supervolcano, by definition, is so powerful that ash goes from 50 to 100,000 feet up. Anyone know what the weather's like up there? Up above 50,000 feet? Cold, very good, true, it's cold and? Windy. What's the wind called? You know?
Jet stream.
The jet stream, very good, sir. The jet stream. And it turns out that the jet stream always blows in the same direction, no matter what the weather's like down here. It's always going from west to east across the entire United States, and it's usually running at about 100 to 110 miles an hour. So it's going from west to east, so from Wyoming to Illinois and other places. And at 100 to 110 miles an hour, it's about 1,100 miles, so the ash gets here to DeKalb in 10 or 11 hours. So, what else would you notice here in DeKalb? What? The sound. You buy that?
Yes.
You'd be able to hear the volcano here?
Yeah.
Have you ever heard a sound from 1,100 miles away?
No.
No. Well, true, but come on. How loud can it be? All right. My skeptic believes it.
Hey, didn't everybody? I heard because when Krakatoa erupted in 1888, everyone was like, "What was that large noise off?"
Yeah, exactly. I had no idea. And you can come give a presentation because you're one step ahead of me. I had no idea when I started writing asphalt that you'd be able to hear a noise. The volcanoes could make a noise that loud. And then I read this wonderful book, Krakatoa, The Day the World Exploded, August 27, 1883, by Simon Winchester. Great book. You like nonfiction, you like reading about volcanoes, read it. And Simon Winchester writes about these British sailors who were stationed on the island of Diego Garcia in the Indian Ocean. Now today there's a U.S. military base there. But back in 1883 there was a British military base there. So these British sailors are sitting around, doing whatever British sailors do. I don't think we want to speculate on that. And they hear this roar! And they think their island is under attack, so they rush down to the beach because they're going to get their cannons and their guns and get ready to fight off whoever's attacking them. They think they're being bombarded by shells. But they look out over the sea. It's calm and clear. There are no ships there. Nobody's bombing them. But this roar goes on and on. They look up in the sky. It's blue sky with just a few wisp clouds. Can't be thunder. And this roar went on for more than 2 hours. Finally, these guys decided there was no internet then. They couldn't look it up. They didn't have a telegraph line then. There were telegraphs, but not to Diego Garcia at that point. And so finally these guys decided that it must be 2 flotillas of ships just off the horizon where the curve of the earth hid them from view. And they're out there having a huge naval battle with their cannons. And that's what's making the roar. But they were wrong. What they were hearing was the roar of Krakatoa erupted 2,953 miles away. So Krakatoa sounded like an artillery barrage for more than 2 hours from almost 3,000 miles off. Yet Krakatoa, it's a normal volcano, Plinian volcano like that. The Yellowstone supervolcano, 2.1 million years ago, in its biggest modern eruption, produced an eruption that was as powerful as 120 Krakatoas going off all at once. So yeah, you hear it here, even in DeKalb. How long would it take for the noise to get here? It erupts, when do we hear the noise? What? At the exact same time? Okay, it's a good guess, yeah, good. 5 minutes, another good guess, thank you. Now it turns out that the speed of sound in air, it varies a lot. It varies according to humidity and temperature and elevation, lots of factors that I'm not going to worry about, but it's something like 600 or 700 miles an hour. and you're 1,100, a little more than that, miles from Yellowstone. So you hear the noise in a little less than 2 hours.